Helicopters are marvels of modern engineering. They can take off and land vertically, hover and fly in multiple directions. These abilities require precise control over their complex rotor systems, often made possible by the hydraulic system. Hydraulics use fluid under pressure to transmit force, fundamental to smooth helicopter operation. Without hydraulics, controlling a helicopter would be incredibly demanding. Hydraulic systems amplify the pilot's control inputs, making manipulation of flight controls easier. This amplification is crucial for precise maneuvering and maintaining stable flight. Hydraulics work on Pascal's law. Pressure applied to an enclosed fluid is transmitted undiminished. In helicopters, a small force by the pilot can be magnified to move flight control surfaces. The fluid used is typically a special type of oil, chosen for stability and performance. The integration of hydraulic systems marked a significant advancement in aviation technology. Early helicopters required considerable physical strength from the pilot. Hydraulics revolutionized helicopter flight, making it more accessible and safer. Today, almost all helicopters rely on hydraulic systems for primary flight controls. Understanding their function is key to understanding modern helicopter operation. This lesson will delve into the components and importance of these critical systems. Hydraulics provide the necessary muscle to counteract and manage aerodynamic forces. They ensure pilots can respond quickly and accurately. The significance of hydraulics in helicopters cannot be overstated. At the heart of any helicopter hydraulic system are several key components. These components generate, store and distribute hydraulic power. The hydraulic pump creates fluid flow, essential for system operation. Most pumps are engine-driven with some electric backups. The reservoir stores and cools the fluid, allowing air to escape. Clean, specialized fluid is crucial for performance. Air in the fluid can cause system issues. Regular maintenance ensures system reliability. Hydraulic actuators are the muscles of the helicopter's control system. They convert hydraulic pressure into mechanical motion, moving the flight control surfaces. The hydraulic system amplifies the pilot's input, producing a larger force to overcome aerodynamic loads. Without actuators, a pilot would struggle to control the helicopter effectively. Actuators allow pilots to make fine adjustments with minimal effort. This ensures safe and confident flying. Section 4. Pressure guardians, accumulators and their emergency role. Hydraulic accumulators are important safety and performance-enhancing devices. An accumulator is essentially a pressure storage reservoir divided into two chambers by a piston or a flexible bladder. One chamber is filled with hydraulic fluid connected to the main hydraulic system. The other chamber is pre-charged with compressed gas, usually nitrogen. The primary functions of an accumulator are to dampen pressure fluctuations and provide emergency hydraulic pressure. Accumulators absorb pressure pulses or surges, ensuring a smoother and more consistent supply of hydraulic pressure. This smooth operation contributes to more precise control and reduces wear on other hydraulic components. In emergencies, accumulators provide a temporary source of hydraulic pressure if the primary pump fails. This assistance can be crucial for maintaining control of the helicopter, allowing the pilot time to take corrective action. The capacity of an accumulator is carefully calculated to be effective in an emergency without being excessively large or heavy. Regular maintenance checks include verifying the pre-charge pressure of the nitrogen gas. Accumulators are often strategically placed in the hydraulic system to provide immediate pressure support. Their role as pressure guardians in emergency backups makes them indispensable for hydraulic system integrity and flight safety. The pre-charge pressure of the nitrogen gas is a critical parameter. It must be set correctly for the accumulator to function as designed. This emergency supply is a vital safety feature. Section 5. Piloting command control switches and system management. Pilots need ways to monitor and manage the helicopter's hydraulic system. This is achieved through various control switches and indicators in the cockpit. These tools allow the pilot to interact with the system and provide vital information about its status. Common controls include hydraulic pump switches, allowing the pilot to turn individual pumps on or off. Warning lights and pressure gauges provide real-time feedback on the hydraulic system's health. Pressure gauges show the current operating pressure, and warning lights alert the pilot to potential problems. Some helicopters feature hydraulic system test switches for pre-flight checks. These tests ensure that the system is ready for flight and help diagnose problems. In advanced helicopters, hydraulic system information may be displayed on multifunction displays, MFDs. These digital displays provide detailed system schematics showing pressures, temperatures, and fluid levels. The design of these controls and indicators prioritizes clarity and ease of use, especially during high workload situations or emergencies. Effective system management tools empower the pilot to make informed decisions regarding the operation and safety of the hydraulic systems. Early detection is key to managing potential failures. This integrated information helps the pilot to quickly assess the overall condition of the hydraulic systems. The ability to test the system provides an added layer of confidence for the flight crew. It confirms that safety mechanisms are operational before takeoff. Section 6. Lifting the load. How hydraulics reduce pilot effort and enhance safety. Hydraulic systems drastically reduce pilot workload by amplifying control inputs, making movements smooth and requiring minimal effort. This reduction in physical effort allows pilots to fly longer without fatigue, enabling more precise control. Fine adjustments to the flight path or attitude can be made with ease, crucial for tasks like hovering or landing in confined areas. When pilots are not struggling physically, they can focus on navigation, communication, and monitoring aircraft systems. This improved cognitive capacity enhances situational awareness and overall flight safety. Hydraulic systems provide consistent and predictable control response, helping pilots develop a good feel for the aircraft. In emergencies, hydraulically assisted controls ensure rapid and smooth control inputs. Many hydraulic systems incorporate features that enhance stability and control, such as hydraulic dampers and autopilot integration. These advanced systems rely on hydraulic actuators for small, precise adjustments, maintaining stable flight even in turbulent conditions. By reducing workload, improving control precision, and enabling advanced stabilization features, hydraulic systems are fundamental to helicopter safety. The ease of control makes flying more manageable. This predictability helps pilots anticipate how the helicopter will respond to their inputs. Hydraulic systems act as power steering for the aircraft. They enable informed decisions regarding the operation and safety of the hydraulic systems. Section 7. Contingency plans. Navigating hydraulic system failures. Despite their robust design, hydraulic systems can occasionally fail. Manufacturers emphasize safety with contingency plans and backup systems. The goal is to maintain control during a hydraulic failure. Redundant systems ensure continued hydraulic power. Warning systems alert pilots to failures. Manual reversion allows direct control if needed. Hydraulic accumulators provide temporary pressure. Emergency pumps offer limited hydraulic power. These systems ensure safe landing despite failures.